Hi, I'm Dan Cornell. I'm the CTO at Denim Group, and I want to talk about a challenge that we've seen with a lot of organizations. That and really what that challenge boils down to is we see a whole lot of people that buy scanners. We see a lot fewer people that make very effective use of those scanners. So we see a lot of people that are buying a lot of technology, whether it's a code scanner or an app scanner, but then they don't get the, after making that technology investment, they don't really get much out of it. So I wanted to talk about some things that we've seen, metrics you can use to look at your application portfolio and the assurance activities that you're undertaking to hopefully get the most out of the technology that you're investing in getting that kind of coverage. For some reason, there's a picture of me on the slide, but with much less hair, I suppose. I guess it's almost time to go and get my semi-annual haircut. But again, I'm the founder and CTO at Denim Group, and I'm a software developer by background. Started out in the mid to late 90s doing a lot of server-side Java stuff, e-commerce and Java servlets and whatnot. Then in the early 2000s, did a bunch of work with the early .NET framework on the Microsoft side of the house. But really for the last 8 or 9 years, what I've spent the majority of my time in my career doing is looking at how software developers impact the security of the organizations that are actually using and deploying their software. And so I come as a software developer who's now focused on the world of security, as opposed to somebody with a more traditional penetration testing penetration testing or IT audit background who's now looking at web and mobile applications. And that I think colors a lot of what I say. I also help. I run the OWASP San Antonio chapter, and so if anybody up here from San Antonio, very good. Look at this. There we go. Welcome everyone. Anybody come up on the free? For San Antonio OWASP members, we had a bunch of people come up here, or offered to come up here for free. Anybody? Okay, well, there we go. All right, the system works. So who here has purchased some sort of an automated scanner, either a code scanner or an application scanner? All right. Okay, good. Almost everybody. Excellent. Static, dynamic, both. Okay, good, excellent. Desktop-based. All right. One of the enterprise or server-based. The cloud. Excellent. Who here is happy with their scanner? One. Nobody else? Kind of. Wow. Yes, one person, 1.5 people for happy with their scanner. I'm curious, why or why not? Why are you halfway happy with your scanner? A lot of noise comes back from scanners. Anybody else? Why do you not love your scanner as much as you could? Anyone? Nobody? Nobody wants to talk? I mean, like the IBM and the HP guys, they can't hurt you. I don't even know if they have any representatives in the audience. Josh, I think you said you liked your scanner. Why do you like it?
It just works. I have it run in the background. It scans every single night. It does its thing. It finds the wrongs. And I seldom have to get involved with tweaking anything.
Well, there you go. Very good. Excellent. Anybody else? Thoughts on why they do or do not like their scanner? No? All right. This is the Friday afternoon crowd. And so the challenge that I see with a lot of organizations, and I think what Josh said speaks to this, speaks to this on the one side. Also, we hear on the other side, a real challenge that we see in a lot of organizations is they have a scanner, but they don't have a system in place to make sure that they're actually using that scanner that's being used on a regular basis, that the results are appropriately tuned, and that when you find things with the scanner, they actually get driven through to completion. And there's, again, those are kind of a lot of steps, but in organizations we've seen that have been successful rolling out scanning technologies, we found that it's important to look at the rollout not from the standpoint of, okay, well, we did our bake-off, we argued with the vendor on pricing. The purchase order finally went through. They cut me a key, sent it to me. I downloaded the scanner, loaded up the key, scanned the heck out of everything I could find, that was nearby on my network, emailed a couple of 300-page PDF reports with color graphs out to the development teams responsible for the apps, and then like a squirrel runs by the window, or there's an incident you've got to deal with, or it's time to update the antivirus or something, and the scanner gets like put off in the corner. And we see a lot of situations where the scanners just don't get used, which is really unfortunate, especially after you spend a lot of money on acquiring this technology, and a year goes past, and your boss walks by and says, hey, how's that? Should I feel a whole lot more secure because we bought $100,000 worth of XYZ scanner? And the answer is, well, you should in a week after I go and like rescan everything. And so, the successful organizations tend to look at this more from a programmatic standpoint. And again, the typical goal is you want to reduce your risk by reliably creating acceptably secure software. And this is something, again, as in a security talk, you've got to have the obligatory people, process, and technology reference. The scanner in this case is the technology, but you've also got to have people that know how to use it. You've got to have the process in place that tells you when to use it and what to do with that. In the spirit of security talks, does anybody have a good Sun Tzu quote? Anyone? I've actually, and I've talked to Jim Manico about this. I want to start replacing. I think that security people might get a lot more done. They might be a lot more effective in their organizations if their talks were all based off of Dalai Lama quotes instead of Sun Tzu quotes. Maybe get a little bit of friendlier image. I don't know. It's whatever. Topic for a different day. But what you see across security programs is there's common activities, and one enumeration of these activities is the Open Software Assurance Maturity Model. And this is an open framework that is intended to help organizations formulate and implement a strategy for rolling out their software assurance or their software security program. And we've had a lot of success using OpenSAM in a couple different ways. It's great to go in and look at an organization to see what is the current state of processes and practices that you have in a given development team. All right, so let's use it as a yardstick to measure how well a specific team is doing. It's very, very useful for that, and it gives you an idea of here's where we're at. It can also be really helpful to set a roadmap out so that you know, okay, well, if I know where I'm at, given using this as a yardstick, what changes do I want to make to my program? And a challenge is that you're not going to be able to fix everything overnight. I mean, that's just the way that the world works. Overall, that's the way that the world works. That's certainly the case when you're looking at software assurance or software security programs, where you have to get folks both from the coding world and the security world, sometimes the IT audit world. You've got to get them to work together. And so we've also had a lot of success laying out a roadmap, saying, well, this is where we're at right now. In this next, over the next quarter, what we want to focus on is getting our static analysis program where we feel like it needs to be. Or over this next quarter, we really feel like we need to get blanket training underway for everyone, and we need to start thinking about targeted training for certain classes of developers. And the main website, this is an OWASP project, the main website is www.opensam.org. And it's currently undergoing some revisions right now, which is good. SAM starts out with 4 different business functions. These are the core activities that any organization that's performing software security are going to be undertaking. And so that's looking at governance. How are you structuring your program? What are the metrics around it? Construction. Let's look at the steps we're taking when we're building software, and how are we? Why, after we're done building software, should we expect that software has been built with appropriate security? Looking at the verification. After we've built software, what activities do we have in place to go and test that software to make sure that we've been successful rolling out or building software with the level of security that we expected? And finally, deployment. Right? Software, once you build it, you've got to deploy it, and then you've got to pay attention to it when it's out in production. Deal with potential incidents and vulnerabilities that are identified along the way. Each of these business functions get broken down into specific security practices. And so for governance, you see we've got strategy and metrics. What are the goals of the program, and how do we measure what we're doing in the program so that we can make a determination if we feel like we're successful or not. Policy and compliance. For better or for worse, I think in a lot of cases worse, compliance is the driver for a lot of software security activities. How many folks here are subject to PCI? Excellent. Sarbanes-Oxley? HIPAA? All kinds of fun stuff. And would you say overall, well, I guess, and I've seen two common cases. I've seen certain cases where organizations wouldn't be doing anything about software security, but because PCI mandates that you train your developers and do penetration testing, they train their developers and do penetration testing. How many folks have been spurred to action by PCI? No? The other challenge that we see in a lot of cases is that PCI comes in and sucks up all the oxygen out of the room, right? PCI says you've got to do all these different things. Once you go through and do all those different things, what you find out is that like 107% of your budget is gone, and and you can't do the things that you actually wanted to do to go and manage risk. Has anybody ever run into that problem? So policy and compliance is understanding what compliance requirements do you have, and what are the policies that your organization has in place to drive you toward obeying the things you need to do for compliance. Finally, under governance, we have education and guidance. I've always, I've got I'm a computer science degree, and I'm a programmer by background, and it's amazing to me that in all the time I spent in undergrad taking computer science classes, which I took a lot of because I was super cool when I was in college, and the only two times we talked about security were in our graphics class when the question was who could show the funniest X window on the professor's Unix workstation, and in a systems administration class where we learned that we could tell them to port 25 and fake emails as if we were professors. Right? Those are the only two times we talked about security in in what I consider to be a pretty good education, vocational education to come out and be a developer, and. Again, security just wasn't something that was discussed. And so what we're finding is aftermarket, you have to train developers about security because they don't typically learn it during the typical education most developers go through. Under construction, so when we're building software, there's a couple of areas where we need to pay attention. Threat analysis. What sort of an environment is this software going to be deployed out into? And what sort of folks, typically malicious, are we going to expect might take an interest in this software? And so how mature are you as an organization of looking at and understanding threats? Security requirements. Again, if you don't train developers how to build secure code, you probably shouldn't expect them to build secure code. And similarly, if you don't lay out requirements for the security of your software, it's not really fair to expect, after everything's said and done, that the software actually has the security properties that you expect. So how mature is your organization laying out good security requirements? Finally, secure architecture. When you structure your systems, are you building them in such a way that you help to minimize your attack surface and to minimize the opportunity for introducing different types of weaknesses and vulnerabilities? On the verification side, design review. What steps do you have in place in your organization to review a design before it's approved? Again, to make sure that it's got appropriate security controls. Then we look at code review, and this is when we see code scanners start to get integrated as well as manual code review. How much of your code base or code bases are you scanning? How thoroughly are you scanning them, and are you undertaking manual assessment activities as well? And then looking at security testing. This is where we see a lot of dynamic scanning activities incorporated. Once the software is up and running, what sort of testing are you doing to see, against the live software, are you doing to see if you were successful building the software you wanted to? And under deployment, SAM looks at vulnerability management. When vulnerabilities are identified, and they will be, how mature are your processes for running those vulnerabilities through a process to say, okay, this is a problem, are we going to fix it? What sort of countermeasures? Let's make the fix and get this thing pushed out into production. Environment hardening. How good is your organization at taking the code you're developing and putting it onto an infrastructure that's going to support your security goals? And finally, operational enablement. All right? Once you deploy software, how good of a position have you put your application operation folks into in order to be able to actually manage and track the security of the security state of the system over time? Each of those 12 practices gets broken out into four different levels, 0 being we're not doing anything in this area. And then you can look through OpenSAM, but they do a good job or a reasonably good job of talking about if your security program has these characteristics, you will fit into a level 1, a level 2, or a level 3, with 3 being the most mature. And so I've found OpenSAM to be a pretty good tool. It's at a good level of granularity. for analyzing a team. It's not, has anybody here had experience with capability maturity model, CMM, CMMI, stuff like that? Did you feel like you got a whole lot of value out of your out of the work you did with CMMI? Unless you're a consultant doing CMMI evaluations, you might not. I haven't seen a lot of organizations that have willingly embraced CMMI, just because it's so ornate, it's so elaborate. And so OpenSAM, again, 12 different areas to measure, 3 different levels for each of them. That's a fairly, it's a tractable level of detail in practice. And so what part does scanning play looking at this overall security program? And so automated scanning, as I mentioned, is both part of the security testing and the code review security practices within the verification business function. And this is a really common starting point for a lot of organizations that are embarking on some sort of a software security program. It's a very natural thing. Again, hey, I've got an application. Scan my application and tell me if we've got anything that's wrong. One huge red flag that we've found in going around and talking to organizations, we say, what are you doing to ensure the security of your applications? All right, if they say, we bought AppScan, right, or we bought WebInspect, or we bought Fortify, or we bought XYZ, right? If the answer is, what are you doing for security, is we bought a scanner, there's a high correlation, in my experience, there's a high correlation between having that conversation and finding out that the scanner may have been purchased, but the scanner is probably not in regular and active use. And again, it goes back to the challenge that is kind of the premise of this, or that we talked about at the beginning, which is we see a lot of scanners being purchased, but less scanner usage. Here's a couple anti-patterns we've seen for scanning programs. There's the dude with the scanner approach. As we're all aware of women in information security, you will all be thrilled to know that this can be implemented as the lady with the scanner approach. It works. It's equally ineffective with both genders. But that's where, again, you go out and purchase a scanner. The week that you get the scanner, somebody runs around, makes a bunch of noise, maybe knocks an app or two over doing some scanning, aggravates a couple development teams with some nasty emails and giant PDF documents, and then nothing happens after that. And again, the challenge there is that you've purchased a scanner. Somebody ran around and used it, but they used it in a very tactical way. Without thought to the follow-up of, okay, well, how are we going to manage these vulnerabilities through resolution? And applications change over time. Just because you scan something once doesn't mean that the next time it's, that after new features get added, after changes get made, fixes and things get applied, scanning is not something you do once and forget. Similarly, we see some organizations say, okay, well, we just turn this over to the cloud. We bought a whole bunch of cloud-based scanning. With the challenge being they're not actually going to see, are the apps that we have signed up for cloud scanning, number one, have we got the scanning turned on? Have we provisioned this? We might have bought 100 units. Have we actually got 100 different scans being run? Is the technology working appropriately? Right? Have I looked to see, am I getting good coverage from the scans, or do we need to tweak something? When we look at scanners, a lot of times with scanners, you run into challenges where you have misses either in breadth or in depth. And so looking at your program, breadth misses occur when you don't understand the entire attack surface of your organization. You don't know the entire portfolio of applications that you have. And as a result, you might be scanning some things, but you're not scanning others because you don't know that they're there. We also see problems where applications don't get scanned frequently enough. Again, these applications change over time. The software changes over time, and if you're not following up scanning activities with future scanning, you run into problems. We also see a lot of challenges with depth misses, where where the scanner's not getting good at crawling of the application's attack surface, where you're not getting where you're not seeing a lot of benefit. Because you're missing parts of the application. Again, if there's parts of the application that exist but that you're not testing, you don't know, and so that sets you up to potentially have false negatives. All right, so you've got you've run a scan, but you missed half the application attack surface. You don't know if there are vulnerabilities there. If there are live vulnerabilities there, you have false negatives. You also run into problems with certain scanning technologies where they have excessive false positives. And that's essentially a denial of service against the security analyst, where if the scanner comes back and says, I've got a million billion vulnerabilities, if you have to wade through all that data, test through each of them, figure out like, oh, actually this is 5 examples of the same vulnerability, or this is an example of a vulnerability, but this it's a false positive from the scanner. That makes your use of the scanner, or that makes the value that you get out of the scanner a lot less effective. We see also some organizations that have some better patterns. In some organizations, it makes sense to do breadth-first scanning, right? And again, you want a scanning program here, not a scanner. But if you have an organization that has a whole lot of applications, right, that you've never looked at before, you may want to find out really quickly, for all the applications that we have publicly exposed, do we have any really disgusting SQL injection or cross-site scripting vulnerabilities, the stuff that are easy to find, easy to exploit? We want to look across the entire portfolio to see if we have any stuff hanging out there that we need to address. Another approach is to do deeper assessments of critical applications, which is typically a combination of automated scanning, manual scan, review, and assessment. And again, depending on the organization, your priorities may be different. You may have a couple critical systems where you have service level agreements with important customers, and you need to ensure, hey, we need to have a high degree of confidence in the security of these applications. Again, or your concern may be, we haven't done anything for software security, and we're concerned, because our attack surface is so broad, we're concerned that we need to take a look at our public attack surface first. It's also really important to understand, and this from folks on the security side, you have to have some context with the development teams, which you may or may not have yet. But scanning is a means to an end, right? It's not the scan is not an activity that has a point in and of itself. The goal of scanning or of testing is to identify vulnerabilities. But once you identify those vulnerabilities, you've got to actually manage those vulnerabilities, which means you've got to run them through to conclusion. So that's an important thing to understand. We see too many environments we go into where we'll come in, do testing, blow stuff up, provide a report with recommendations, come back a year later, do the same testing, blow the same thing up. And we're like, you've known about this. This is important stuff. Or if you've known about it for a year, why haven't you done anything about it? And again, that comes back to having poor vulnerability management practices in place, so that even if you're finding vulnerabilities as a result, if you're kicking up vulnerabilities as a result of doing a bunch of scanning, if nothing ever happens with those vulnerabilities, you haven't really gotten a lot of value out of the assurance activities that you've undertaken. So what goes into a successful scanning program? The first thing is a solid understanding of your organization's attack surface. And this is something that is very, very, I've found to be very important. I've been in very scary meetings where folks that work in the same organization, discover that their application portfolio is growing by leaps and bounds. All right, where they say, okay, well, we've got this application. Well, what about the version that we stood up for this important customer? Oh no, that application's been taken down. No, it hasn't. I had to respond to an incident on that server, a couple weeks ago. Okay, well, now we have twice. Now we have 2 applications up instead of 1. And people go around the table and you find more and more applications that got stood up and things that never got end of life. And so in a lot of organizations, nobody has a really good handle on what the organization's attack surface is from a standpoint of what web, software, and other systems they have. And things like mobile and things like the cloud have only made that worse. Does anybody here feel like they've got a good list of apps in their organization? Anybody? Yeah, this guy? Congratulations, excellent. Nobody else? Yeah. You also need to have a realistic concept of scanner effectiveness. There's certain vulnerabilities that a scanner is going to be able to find in an automated way. There's other classes of vulnerabilities that automation is simply never going to be able to find. And usually I see that breaks down between coding flaws like SQL injection, cross-site scripting, that scanners, both the code scanners, both the static and the dynamic scanners are pretty good in a lot of cases at catching. Versus more design or architecture-oriented flaws that deal with the business logic or the specific requirements of a given application in the context that, in which it's deployed. And so it's important to understand, for this scanning that I'm doing or for this testing that I'm doing, what am I really getting out of that? How thorough of insight do I have about the application, about the security state of this particular application? Another thing that we look for is a disciplined history of scanning. Again, as applications change over time, you need to go back and retest. And maybe you only need to retest parts of the application. Maybe for certain releases you need to retest the entire thing. But again, these applications typically don't, number one, the attackers don't live in a vacuum or don't live in a static environment. New attack techniques are developed, and so that's something to pay attention to. But in addition, and more important in most situations, applications change over time, and it's important to make sure that this is an ongoing activity. It's not a one-time activity, but it's a program of ongoing scanning. Finally, the prioritization of your testing efforts. If everything is if everything is important, then nothing is important, right? So if everything is equally, if every application is a critical, then you might as well say that every application is a low, right? You have to be able to prioritize, and unless somebody here works in an organization with an infinite budget, infinite resources and infinite budget for software assurance and testing, you're probably going to have to make some trade-offs to determine which applications are we going to look at in a cursory fashion, which ones are we going to select for deeper, for deeper and more thorough assurance activities. And so, what we see is a progression in a lot of organizations, looking at, as you try to determine what is your software attack surface. So you start out with the software that you currently know about. A lot of times these are critical legacy systems, notable web applications. These are the applications where a lot of value flows through it, and so everybody knows about it. Your auditors, again, if it's subject to PCI or something, your auditors are probably hassling you about it. In a lot of cases, we see organizations that have formal SLAs for application performance and security with important customers. You may know about an application because a bad guy found it before you did and managed to do something wrong, so you had an incident. But again, in most organizations starting out on this journey, there's everybody in their head has a couple ideas of these are the applications that we know about. Because these are the ones where a lot of value is flowing through. Then organizations start to figure out well, let's figure out the rest of the web-based systems that we have. What are the different lines of business that we have, and what applications have they deployed in support of whatever stuff they're doing, right? Or what are the one-off pieces of software that we've developed to support some specific function that now actually lives there? Why'd you miss this originally? You may have forgot it was there. The line of business might have procured it through some sort of a non-standard channel. In a lot of cases, this problem gets infinitely harder if you're in an organization that does a lot of mergers, right? Where all of a sudden you're like, well, we've got our applications plus all the applications that these maniacs down in Atlanta have as well, or whatever the particular situation is. If you push even farther than that, then you need to start looking at the software you bought from someone. And that speaks to the things Joe was talking about in the last session, talking about the software supply chain. Right? It's not just the software that you're developing. It's the components that roll up into that, as well as the software you're buying from other folks. Again, a lot of these done in support of line of business, things that support infrastructure, and again, why did you miss them? Well, a lot of scanners only really work well on web applications, and so you're probably not going to know, you may not be thinking about your client-server applications or other things like that. A lot of people assume, well, I'm sure I'm sure the software vendor has gone and done whatever due diligence they need to before they sold me the software. And finally, the kind of the last set of things we see are mobile apps, right? The cloud. Now I love the cloud because now everybody with a $500 limit purchase card is now their own purchasing officer, right? Everybody with a credit card in your organization is now their own purchasing department. Yay. Think about shadow IT. Same thing with mobile applications. We see in a lot of cases these get procured through non-traditional channels. Mostly because some group, a line of business says, it would be really great for innovation if we had a mobile app that would do X, Y, Z. We could really serve our customers well. We could build a lot of value if we had a mobile app that did this. And they go to their IT department, and the IT department says, sure, we'll get our developers on it. They can start gathering requirements in 2 years, and you can expect your software 2 years after that. All right? Or they go to the security department, and the security person says, whatever you're asking, the answer is no, but you still need to fill out these 3 forms for me. Right, and so naturally, all right, a spunky employee, who likes to be rewarded for accomplishing their goals, then goes to find some offshore developers that are more than happy to put together some software. They'll even put it in the App Store for you. And so what we see are with the cloud, again, and with kind of newer technologies like mobile, we see that they don't get procured through the normal channels, and so it's easy to add to your organization's attack surface and not even know about it. And it's interesting. It's been interesting to me to see different ways, both technical and non-technical, that that you can use to find these things. There's a startup. I think they're called Cloudability, and their whole deal is that they help organizations optimize their cloud spend by going in and working with their accounting department to figure out, like, oh, by the way, do you know that you guys have 72 Amazon AWS accounts? Right? Maybe if you pooled those together, you'd find that you could get a little bit better volume pricing. Or do you know that you have 17 different instances where you've purchased Salesforce or whatever else? And so similarly, non-technical means going through and talking to disaster recovery folks. Right? Hey, what do we have disaster recovery plans for? Right? If something's important enough to have a disaster recovery plan, it's probably important enough to think about the security of it. And so that, in addition to using network scanning and things like that to identify a web application on different segments of the network. And so the attack surface is really like the security officer's journey. Is what's your insight into the attack surface? What's your perception of the attack surface? What assets do you understand make part of that attack surface? And what level of insight do you have into those types of applications that your organization has developed? So you think, oh, okay, well, web applications, that's something we need to worry about. Client-server applications, yeah, that's probably something we need to be concerned about as well. Desktop applications, those may, those probably have, potentially have security implications as well. Cloud applications, mobile applications, and so on and so forth. Also, you see that, hey, we have some discovery activities. We find a couple. We go and ask a couple people. We find some more. And over time, what you see is a progression. And once you understand all the different things that expose you to software risk, and you have perfect insight into it, I believe they call that enlightenment. And I don't believe anyone has ever reached that stage. Another important thing, and when we talk about the depth of scanning, if you, and we've seen this, a lot of challenge in this with procurement language, right? When people are going out and looking for testing services, what are you actually getting when you have, when you get an application test, right? Because there's a lot of things that could potentially go into that, and it's important to understand, when you want to talk about the thoroughness of the testing that you're doing, you need to understand which components of the available testing types are out there that you've undertaken. Right. And again, this, for most organizations, you're looking at dynamic analysis versus static analysis. Am I testing a running application, or am I looking at an application that is, the artifacts, the source code of the binaries? We look at automated application scanning. Again, great at finding certain technical flaws in applications. Not great or completely incapable in a lot of cases of finding business logic type flaws, logic flaws in applications. Right? And that can be applied both to dynamic analysis as well as static analysis. Right? Source code scanners, great at finding certain things with control flow analysis, data flow analysis, but they don't understand that your application is dealing with credit card data. Or they don't understand the environment your application is deployed out into. And so there's a lot of things, there's a lot of flaws that you can only find in cases where you are doing manual code review as well. Are your scans unauthenticated or are they authenticated? A huge problem that we've seen before in the past with folks is they'll turn on the web scanner, point it at the application, it scans the home page and the login page, no vulnerabilities, declare victory. Yay, my application's totally secure. Granted, there's 500 pages behind the login that the application never saw, but the scanner said it was clean, so I guess we're secure. Same thing. Looking at penetration testing. Is this blind penetration testing, or is this something where where the folks are starting out with some information? And finally, looking at the static analysis, you've got automated review. Are you looking at the source code? Are you looking at the binary? So on and so forth. And so it's important when you look at the testing that you're performing to understand these are the components, these are the activities that went into this test, and as a result, I should expect that we have identified, or we would have found whatever vulnerabilities I should expect to find with that type of testing. Again, if everything is critically important, then nothing's important. Some applications matter more than others. Each organization is going to have a different way of determining this. A big driver that we see in a lot of cases is the value or the character of the data being managed by an application. That's what you see when, with things like PCI. Hey, does this application touch cardholder data? It does. Cool. Well, now it's in scope for PCI. You also look at the value of the transactions being processed, and the cost of downtime. If this application goes down, is that something? The company picnic application. Maybe people are sad, nobody can sign up for the picnic, or too many people bring coleslaw or something. But at the end of the day, not a bad thing. Contrast that with your online banking or transaction processing system, where downtime is a lot more important. And because of this, you can't treat all applications the same. You've got to put different levels of resources toward assurance activities based on the value of the application. And you'll select different activities, and again, unfortunately in a lot of cases, all this has to be done within the constraints you have as a result of the regulatory system that you in your organization operate under. And so you want to allocate different levels of activities to these different applications. We've put together a system and released it open source, and I'll run through a quick example of this that helps to address some of these things. And it's called ThreadFix. It's available off of Google Code under Mozilla Public License. And it lets you do a number of different things. It lets you build up your application portfolio and characterize the applications in the portfolio. How important are they? It lets you store the results of different assurance activities. You can load in scans from a lot of the popular free and or open source and commercial, both dynamic and static scanning tools, as well as things that you find from from manual penetration testing, threat modeling, and things like that. So you can start to store all the results of your assurance activities in one centralized place. And that's good because what that starts to let you do as you track scanning over time, so if I'm loading scans in over time, each time it gets a new scan, it diffs it against the previous one to find out, have new vulnerabilities shown up, have old vulnerabilities gone away, have previously fixed vulnerabilities resurfaced. And what you find is as you start to do this stuff over time, you can start to track some metrics on your program. And so you no longer have a collection of unrelated assurance activities. Right, I've got a drawer full of 300-page PDF printouts from all these scans. Instead, you're treating this stuff as data, and you can start to have a much more quantitative description or a quantitative discussion with the powers that be in your organization. All right, we'll go through a quick demo. Yesterday, I was given demos at another organization, and my laptop had a hard crash right before my demo started. Today, my system is running really slow, so I'm sure this will turn out well. So when you log into ThreadFix, you first see just a kind of a basic dashboard that shows you, some trending over time, of vulnerabilities as they show up and they go away. What's the level of criticality? And you also see, what are the applications that we have? What are our top 10 top 10 most vulnerable applications? Here we don't have a full 10 apps loaded in. You can also see recent scans that have been uploaded, and you can see that Jim Manico typed some things into my computer earlier. And so there's some collaboration capabilities in there. Oops. Give this a second, because my laptop hates me today. But then you can drill into the applications. And as I said, you can start to upload the results of your scanning. So if you're running AppScan or something like that, and you're running it over time, you can load all this data into one central location and start to track what vulnerabilities you're identifying in these applications. And again, as you start to do this, you can track it over time, so you can start to see trending data. So the advantage of storing all this stuff in one place is again, that you can start to report on this data. And what we've seen is it facilitates a much better conversation with management. If you go to management and tell them, software security is the thing I'm concerned about this week, and cross-site scripting is scary, right? if you go to an energy company, right, and you go to their CFO, or an airline company, you go to their CFO and you say, cross-site scripting is scary. What they're going to tell you is, hey, every time the price of a barrel of oil shifts by $1, I lose $20 million a day. That's scary. Cross-site scripting is not scary. All right. If you go to an energy company CEO or your risk manager and you say, hey, cross-site scripting is scary, they're going to come back and they're going to say, well, you know what? We had 8 guys kidnapped in Congo last week, and one of our guys got like eaten in Papua New Guinea last year. Like, that's scary. Like you want to talk about managing risk? Those are the risks that are really impactful in my business. That's the stuff that we're scared about. But okay, now everything's working great. But a cool thing that you get when you start to track these scanning activities over time is that you can see, hey, what's the prevalence of certain vulnerabilities, right? What percentage of those vulnerabilities have I fixed? Is everybody here familiar with the reports, either or both from White Hat Security and Veracode? Everybody seen those in the past? Excellent, yeah. Great stuff, right? Where they've looked over all the scanning that they've done, and they can talk about, hey, for this industry, companies of this size, we have, they see this much SQL injection, this much cross-site scripting. They've fixed this percentage of the critical or high vulnerabilities that they've identified. Like, really, really cool data, because what that lets you do as an organization is you can start to benchmark against that. Right? If you've got a report like this that shows what are the different types of vulnerability, how many have we found, what are the percent that we've fixed, what's the average age of the remaining, and what's the average time it takes me to close, all of a sudden that puts you in a situation where you can start having a grown-up conversation with management, where you can say, here's third-party data about the state of the software security industry. Right? As you can see, peer organizations to us fix vulnerabilities on average in 50 days. We're fixing vulnerabilities on average in 75 days. This is something we need to devote more effort to, right? We are falling out of step with our peers. We need to devote more effort to this. Or you could say, hey, in industry, it takes people 50 days to fix this. My team is fixing them in 25 days. Clearly, I deserve a bonus for my effective use of scarce resources. However you want the statistics to lie, you're more than welcome to use them. But the important thing is now you start to have actual statistics. You can start talking in a quantitative way about how your program is working. And that's a much more powerful discussion to have when you're trying to justify budget, when you're trying to justify headcount, when you're trying to demonstrate, hey, you spent $100,000 buying technology XYZ. As you can see, we've discovered this many apps in our portfolio. We've identified these vulnerabilities, and now we've got and now we've managed to actually fix a lot of this stuff as well. And so that's a great way, again, to speak in a quantitative manner about what you're doing in your organization, how successful you've been, and to use that data to then go and justify further activities. And again, that's you can download that from Google Code. The 1.2 final release just came out last week, 2 weeks ago. So, in closing, kind of steps for improvement. Really important to build your application portfolio. Too many organizations have no clue what their application attack surface looks like, and you cannot reasonably expect that you're going to be able to defend application attack surface that you don't even know about. Any sort of assurance program to be considered an actual program, you've got to have at least an idea of what your attack surface looks like. I think it's important to characterize the effectiveness of the efforts that you've made to date. What assurance activities have you undertaken? What was the value that you got out of those? Then you need to build a plan for coverage. Now that you know your attack surface, you've got to have a plan to figure out, if I have this level of resources, what can I reasonably expect to cover? And for this coverage, what depth of insight should I expect to get out of that? And you've got to monitor progress over time. These aren't the types of things, especially in a space like software security, where you have to have the intersection of development teams, security teams, IT audit teams. All of those folks have to come together and talk about trade-offs between cool, fancy new features and functionality versus fixing old problems and addressing technical debt. This is something that doesn't happen overnight. It's something that has to happen over time, again, which is why I think it's really valuable to have to have this trending and historical data that you can look back to. The bug tracking capabilities, yeah. And so one of the things that you can do that I forgot to mention. So the question is, hey, what are the bug tracking capabilities? We give, like in ThreadFix, what you can do is you can go in and slice and dice your vulnerability data and ship it over to defect tracking systems. And so if you've got a scan with 100 cross-site scripting results, right, you probably want to get those in the hands of developers, right, so that they'll actually fix them. You probably don't want to take 100 cross-site scripting vulnerabilities and turn them into 100 bugs, because then the QA manager will murder you in the parking lot, right? Because that's just not how, it's going to take more time to administer the bugs than it will to fix them. And so what you can do is you can go in and say, well, let's break this up into blocks of 15, or let's take all the bugs in a certain part or all the vulnerabilities in a certain part of an application and make that a bug. And so you can bundle the vulnerabilities up, ship them over to defect tracking systems, and then ThreadFix pulls the defect tracking systems on an ongoing basis to identify when the developers say the bug status has changed. And so you can see when the developers think that they've fixed the problem to schedule a new scan. Right now we have out-of-the-box integrations with Bugzilla, Jira, and Microsoft Team Foundation Server. There's a cloud-based bug tracker called version 1 that we also have tentative support for, and there's a plugin API so that if you have another bug tracker that you want to use, you basically just implement a Java class. There's like 6 or 7 methods that you need to implement to give me a session, make a bug, check a status, and things like that. And so out of the box we've got kind of 3 or 4 popular systems supported. And then what we see is there's kind of a really long tail with defect tracking systems that the different folks use, and so we've tried to make it as easy as possible. We've got example code on the project wiki and things like that. Great question, thanks. Any other questions? All right, well, thank you all very much.